Engineering Eng. PDF document of this video is on engineereng.com.
Hello my friends, today I want to give you information about gradients, divergence, curl and Laplacien. First of all, I have to start to say that after understanding these, we will use them in many questions, so what they mean is very important for us. First of all, I want to start with this. What we call a gradient is any scalar. Notice I used a scalar. It means the scalar multiplied by the nabla operator. Yes, the nabla operator here. Let's write it like this. What does the nabla operator mean? So guys, observing how much the derivatives change in all directions. Now, let's write the nabla operator first. Nabla operator dividing and differentiating the corresponding direction vector by its metric and likewise the metric of the second direction vector. Okay? I'm fixing here the derivative according to the relevant direction. Likewise, it is found by differentiating the third direction vector as follows. It is also found by dividing by its metric. Now, then, when you look logically here, when these are the direction and f is multiplied here, can we actually say that the result of dlf is a vector? We can say that it gives a result like a vector such as a. We can say that I got the scalar in. So here we multiplied by scalar. Ultimately, the result that will emerge from this due to the directions in the nabla operator, since it always takes a direction vector in front of it, our result will always be vectorial since it will always have a direction vector in front of it. Who should we look for here now? We are looking at DLF. Let's look for who, friends? Let's write here for cylindrical coordinates, okay? I'm writing for CYL. Let's write for cylindrical coordinates. So, will it be like this? E rho over H rho, DLF over DL rho, plus E phi over H phi, DLF over DL phi, plus here, of course, what we call K will now be Z. Ez divided by Hz. We can write DLF over DLZ. Of course, if we organize this further, I can read it in the last DL when it is scalar, okay? Now, if we arrange DLF like this, if E rho DLF over DL rho plus, we need to write E phi divided by more precisely as follows. E phi 1 over rho. You know H phi is equal to rho. You write DLF over DL phi plus EZ DL F over DLZ. Now, this has been a gradient operation for us, okay? Now, come to the difference with divergence. What is divergence? Now we show the divergence as follows. Divergence means we derive any vector and we have a scalar forming what I mean. Divergence means we derive any vector and we have a scalar forming what I mean. Let me put it this way. Divergence is done with a vector. For example, something like G came out as a result. What is the logic here? After all, this has direction vectors in it. What happens when we multiply it by the corresponding direction vector? You know, when EI times EI in scalar product, this is equal to 1. Okay? I threw if EI times EJ times com, of course, provided that I is not equal to J there. At that time, if the result is 1 from here, what happens automatically? 1g comes in size and we don't have a direction vector. Now when writing divergence here, our difference is that we can show it as follows. I find the divergence. For example, the related direction vector. So let's write like this with the total symbol if you want. I is the product of all direction vectors from 1 to 3 dl over dl, the corresponding direction vector. Then let's look at the unrelated, the rest. We will understand this better in the example a little later. Here is the vector of A in that direction. That is our vector right here. A can occur in 3 directions. It can occur in 1 direction. So since I don't know, I write in the form of AI. What I mean now? I'm writing again for cylindrical coordinates. It's for the cylindrical coordinates. So I'm writing by opening the printer as follows. 1 over h rho, h phi, h z. dl divided by dl rho. You know what? We'll write the first I is rho, my friends, yes. Then the unrelated ones, that is those outside h rho. h phi, h z. Then, for example, I wrote the component rho of A as follows. Okay, I'm writing like this. I say plus 1 over h rho, h phi, h z, dl over dl phi, h rho. This time I wrote the non-phi as h rho, h z, and a phi. I keep going now. There is a plus here. Then I say again plus 1 over h rho, h phi, h z, dl over dl z. I wrote the rest except z as h rho, h phi, and a z. Now write it like this and edit it here. Okay? Divergence A equals, of course, we do it for the cylindrical coordinate here. What happens here? H rho 1, H phi rho, H z 1 would be like this. Of course, what you need to pay attention to here is the derivative here, okay? Please pay attention. If this is scalar connected to rho, there is also rho in H phi. Okay, so let's write this to be clearer, okay, my friend? The product of these 3 is rho, okay? I have 1 over rho, dl divided by dl rho. I open brackets h phi rho, h z 1. I write as follows rho, a rho. I want to say this here. I take derivative. You know, here this is also connected to rho. Since this is rho, we normally need to take the derivative of the multiplication. So if we want to open it further, so the derivative of the first time itself, the derivative of the second time itself. I leave it like this without doing it. I'm going over here, rho dl divided by dl phi h rho 1 hz1, then automatically here a phi remained. I wrote the direct a phi like this. After that, see who was left. Let's come to the third place. Something different is going to happen here. Here I wrote 1 divided rho again. I wrote dl divided by dlz. I opened my parentheses. I know that h phi is rho, h rho is 1. Then there is a 1 rho here too. There is rho, there is az. I want you to notice that this is scalar connected to z. Here is rho, by whom derivatives are taken. It is derivative with respect to z and does not depend on rho z. Then I can automatically get it out. As I can take it out, I can simplify it with the rho over here. That goes with that. But it can't go with this and that because this one depends on the rho. This one depends on the rho. So I'm rocking here. You can think of something like x times 3x squared, so I can't just pop it out because both are linked to rho. It is necessary to take the derivative of the normal multiplication. That's why I leave it like this. Here we can write by cancelling its way. Let's write the final version without feeling lazy. Okay, my friend, understand these places important, friends, because after understanding them, I do not think much of an unfamiliar situation arising. That is why I try to go here by emphasizing a little more, okay, so that you can understand it better. I hope it helps to you guys. I hope. Let's write I like that. 1 over rho dl a phi over dl phi. The following rows were simplified, so we calculated the divergence in the form of what was left. dl az divided by dlz. Now come here, what's our previous topic? You see, we saw the gradient, we saw the divergence. Now, after seeing the divergence is the curl next. Now I'm trying to explain curl. I do not forget to mention this here, let me just say that, guys. Since there is no direction vector left as a result of this divergence operation, a function like g will come in the middle. So let's write this g. For example, like this. Let the divergence A be equal to g. Which is equal to, let's say, linear and cyclic. Linear and cyclic. In which cases we call it linear and in which cases cyclical. Now this means that, guys, the arrival of the results of divergence is the operation where we question whether the field lines emerging from a source reach the source again or not. Is the line coming to the source or not? Okay. The logic of this is the divergence linearity test. If the result of the question is linear here, if our result is different from 0, yes, it is linear. So if g is not equal to 0, it represents that the field lines we tested, the scalar lines of a moving in the directions, do not return the source. That is, it's linear. Okay? What does cyclic mean? Is there a loop according to the name? if the result of linearity is 0, that means I could not succeed in the linearity test. I couldn't find a linear situation, then it automatically shows that it is cyclical, guys. Okay? To whom shall we come next now? Let's get to the curl operation. With curl, the situation is a little different, my friends. Curl is the opposite of divergence. Let's just say this before. So, curl means that the cross product is done, and automatically when I cross the direction vector, if you remember what it was doing, it will give us another direction vector in the form of a projection to another third direction vector. Because you know, EI cross EJ will give me another direction vector. So we understand from this result that the result of B here is vector. Now let's say this from here. How do we do this? For example, before I do it in cylindrical coordinates, let me give the general equation like this. dl cross A is found as follows. Hi, hj, hk, and hi times, for example, hi times ai. I'm correcting. First, the direction vectors are written, guys. Okay? Be careful. Now here, the first row is multiplied by the EI matrix. Okay? Which are the common direction vectors of the first and second row. So it is written as the metric of the relevant direction vector, guys. The metric of the relevant direction. The metric of the relevant direction. Let's write like this, okay? So it's written this way. I couldn't draw, guys. I'm correcting it, sorry. Then what is the first element on the left that crosses the second part here first? Now the first element on the left. You write derivatives this way because of this derivative. So dl over dli, dl over dlj, dl over dlk. In the last part, we write together with the matrix, my friends. This time the components of the hi, that is the second part element to be crossed, are written, okay? hi, ai, hj, ha, hk, and ak. I'm writing, sorry. hk and ak again. Well, let's test it again how you wish to print it. For example, let's write again for cylindrical coordinates. Let's write dl cross A in cylindrical coordinates. Okay, I'm writing hi, hj, ak 1 over rho, hi, ei, so just e rho from h rho, e rho, because here h rho 1, I didn't write it, you know. We call h phi rho, hence rho e phi, hk 1, so hz 1. So my third direction vector 1 is just ez. Elements of the first derivatives, dl divided by dl rho, dl over dl phi, dl over dlz. I would like this. And finally, this second element is written as the vector A times the matrix. Let's write it like that. A row, row A phi, that is H row, 1, H phi row. Where did I come? HZ, 1 will only stay a Z, okay? So, this is how it is written in the curl operation, my friend. Here's who finished after the curl operation. Let's do it like this. After finishing curl, let's move on the one we call Laplacien and even the most necessary ones for us. The second order derivative that we call Laplacian is an upper version of the gradient, guys. Let's write it like this. Laplacian, let's write it in parentheses, dl square f. So if there is a quadratic derivative, how is it written? I'll immediately show it to you with the total symbol. I will show like this. dl squared f, I means I will write from 1 to 3, that is in 3 directions. We write hi, hj, hk again. Notice this time, as in divergence, there are those who are unrelated, okay? In other words, those who are not interested are others. But this time, we are also rewriting the only relevant ones. Of course, I forget something. There will be 2 derivatives, right? There will be 2 derivatives. One here with respect to dl divided by I multiplying by that. Then driving again and then writing f. So what did I mean? Let's do it again to understand what I said. Now, I say it again for this cylindrical. Since cylindrical has the middle of the both, the other one is directly, for example, in Cartesian, these places will not be forced. I think if we make the cylindrical, you can make the sphere yourself. So I'm going to write you again dl squared f for cylindrical. Let's write, I say equals. Now you know that the product of h row, h phi, hz is 1 over rho. I started with dl rho. I opened parentheses. Which ones are not related to rho? h phi and hz. h phi and hz over h rho. Let's write without lag so that you can understand better. Okay, guys? dl rho plus 1 over rho, dl over dl phi, unrelated with respect to phi, h rho and hz, okay? Related one, h phi. In phi, the phi becomes relevant. I put dl divided by the dl phi. Plus, let's finally do it like this. It means our process continues. I came to plus dl over dlz. Unrelated ones, h rho and h phi. And related ones, hz. dlf over dlz. Let's edit it now. dl squared equals f 1 over rho. Now I'm showing that above and I'll show that over again. I wrote 1 over rho, h phi rho hz1, h rho 1. So here I write this first. dl divided by dl rho, parentheses, rho come from here and come 1 here. Just rho dl of dlf over dl rho. Look again, guys. Let me tell you a little later. You have more or less understood what I mean. There is 1 over there, then it becomes like this. 1 over rho dl divided by dl f. I opened parentheses. These are 1 times 1, 1 over rho. I wrote it as dl f over dl phi. Finally, 1 over rho, I came to the third dl over dlz, so I came to z. I opened my parentheses, h rho, h phi, rho 1, 1, then only here rho remained. What is left here? dlf over dlz. Okay, I wrote like this. Gradient software is important because we usually solve the Poisson equation, so the questions are necessary for us. Guys, watch out now, guys. Look, my friends, my dear friends. Here is the derivative of the first times the second. I can get it out using the rule. So I'm not touching here. See, I can touch but not touch, but we can do it according to the rule we call. Check here now. These a rho here. There is a rho here. Look. When we are about phi, can we take rho? Yes, I take it out. I cancel this and I will bring two of them here. Let's write that rho a little properly. Okay, guys. Now is this about that? Not. So imagine I got this rho out first. Then from here, rho divided rho. These rows simplify, and with this goes. Let's write this final version without feeling lazy. At some points, friends should not be lazy. Okay. Finally, here dl squared f is equal to 1 over rho. dl over dl rho. Rho times dlf over dl rho plus 1 over rho squared dlf dlf. Is it like that then? dl squared f divided by dl phi squared plus dl squared f over dlz squared. This is where the logic of these softwares always come from, friends. Here is the only point we need to know by here. Once you know how to write this formula, you create this yourself. Okay. You can do it everything if you know that. But a person who solves all these many questions can now easily write these. That's why I don't think it will be too much trouble. Finally, let me remind you one last thing. I forget to tell you again. I just told you in this result, if the result is different from 0 to the question of whether this linearity, if a number other than 0 comes, then the linearity test is successful. So if the result is non-zero, we can say this is linear. And I forget to say that here is the opposite of curl. If that is the result of the curl process, it is called the rotation process. If a non-zero result comes from the rotation process, it tells me that it is cyclical. In other words, the lines emerging from the source show that fields are returning the source. If it comes to 0, nothing is returning to the source, and it's linear, okay, all of them. Let's summarize for the last time, guys. Let's say this in our summary. If divergence A is equal to 0, it is definitely not equal to 0, guys. Okay? Or let's say that if this is 0, then this time divergence A is not 0. So this is the summary. A field or ray is either cyclic or linear. Cyclical or linear, my friend. The result of the divergence operation was 0, so it failed the linearity test and gave the result 0. In the cyclic test, it did not give a result like 0. Yes, I was seen to be cyclic. So this is cyclical as it cannot give a non-zero result to linearity test. Okay. Likewise, you know that it could not go through this cyclical process and gave a result like 0. Here it passed the linearity test, that is, it gave a result other than 0, then it passed the test. It is linear, guys. We have summarized this way, friends. Thank you for listening. Hope to see you in the next video. Goodbye for now.